Hey guys, welcome back. And I got some questions yesterday about this assignment and more specifically how to answer these practice questions based on this chart. So in order for me to do that, I feel like what I need to do is really tell you a little bit more about um, what a coolant system is. So let's take a look at this real quick. A coolant system is part of an engine that keeps the engine from overheating. So this is a really complicated diagram, but forget about all these little arrows and labels and the intricacies of it and just look at it big picture. So here we have the combustion chamber of the engine. This is what makes the engine go. Gases go in here, they explode, and the energy from that makes the piston move. That creates a lot of heat, and if an engine was to run on its own, it would overheat very, very quickly and break down. So what we do is we use these coolant systems. So cold water comes in, and this cold water surrounds the pistons. And as the pistons do their job, they release heat, and it gets absorbed by the water. That now heated water goes away from the piston and gets recooled, and then more cold water gets pumped in. So we have this continuous system of cold water being brought to the pistons of the engine and then hot water being brought away so that it can be cooled back down. So this is a great system that keeps engines running for extended periods of time. But what happens when we don't have antifreeze when the temperature goes below freezing? So it's winter in New York City, you go out to start your car, and the coolant system has frozen. If the coolant system is frozen, then we're not going to be able to effectively cool the engine, and the engine will overheat and shut down. So we have to make sure that our coolant system never freezes. So our colligative properties, in this case our solute is ethyl glycol. If we increase the concentration of solute in a solution, it will push the boiling point up and it will push the freezing point down. It'll have to get colder and colder in order to freeze. So when we put antifreeze into our engine, it prevents the coolant system from freezing when the outdoor temperature gets below freezing point. That's 32 degrees Fahrenheit or 0 degrees Celsius. So if we have a little engine, we only need a little bit of antifreeze to get the concentration of solute high enough to push the freezing point down. But if we have a really big engine with a high capacity, we're going to need more of the antifreeze in order to push the concentration high enough in the solution to get the freezing point lower. Bigger engine, we're going to need more antifreeze to hit the same concentration that we would in a smaller engine. And that's why we use this chart. The capacity here is the size of the coolant system, right? The bigger engine is going to require a bigger coolant system. Smaller engine, smaller coolant system. And here is the quarts, that's the volume. How much antifreeze are we putting in here? So if we have a really, really small engine and we have a small coolant system, we only need 3 quarts of antifreeze to protect all the way down to negative 7 degrees Fahrenheit. But if we go up to a bigger engine, say go up to 13 quarts, now this coolant system is big enough that if we only put in 3 quarts of antifreeze, it's not going to protect down to that negative 7 degrees. If we put in 4 quarts, it's only going to protect down to 3 degrees. If we put in 5 quarts, it's going to protect down to negative 9 degrees. If we put in 6, it'll protect down to negative 25. So this is a question that's not on the table, or not on your work. This is one I just made up. How many quarts of antifreeze are needed to protect a 14-quart coolant system to 20 degrees? So if we have 14 quarts and we want to go down to 20 degrees Fahrenheit, the forecast is 20 degrees. If we put in 4 quarts, that's not going to cut it because this engine will freeze. If we put in 5 quarts, it'll protect down to negative 5, but that's still not going to cut it because our temperature is going to be negative 20. 6. That's close, but negative 20 is still colder than negative 18, so it looks like we're still going to have an engine freeze. we have to jump up to 7. Yes, 7 protects to negative 34 degrees, which is 14 degrees colder than we expect, but you always have to go on the safe side. You have to build in that factor of safety. It's forecasted to be negative 20 degrees Fahrenheit, so let's protect all the way down to negative 34. We're not going to use half bottles. We're not going to say, just a sprinkling of the 7th quart. Don't use the whole thing. Now, go with whole bottles. So if we need to get down to negative 20, we're going to have to not stop here. We're going to have go all the way to 7. So 7 quarts, which would protect all the way down to negative 34 degrees Fahrenheit. That's how we use this table. That's why antifreeze works, and that's why coolant systems are important. So I hope this video helped, and those of you that have not done the assignment, I hope it's helpful when you do it, and for those of you that are still working on it, I hope this clears up some confusion. Thank you very much.